Communications is one of the key words we hear as we move toward the 21st century. During this program, we will look at 3 communication technologies: the cellular telephone, xerography, and the talking computer. It would seem that solitude, on the rise in major centers, has brought out in us a special affection for the telephone. We can't resist it. In highly developed countries, households do not have a phone. They have several phones. Better yet, the cordless telephone, the solution to all your problems. It folds so you can slip it in your pocket. Soaking up the sun beside the swimming pool or at work in your garden, nothing will be able to keep you from answering that all-important call. And their self-rechargeable batteries let you talk non-stop for up to 2 hours. I've got to stop this. I feel as if I'm doing a commercial. It's just that these phones have become so accessible in recent years. The same thing goes for cellular telephones. They're becoming so popular. Chances are that in 10 years' time, they will be as widespread as car radios are today. The cellular telephone relies on radio technology as much as it does on telephone technology. In cellular telephone communication, the conversation of both parties travel in the form of electromagnetic waves, like radio communication, and in the form of electrical impulses, like conventional telephone communication. When the user picks up the handset of a cellular telephone and dials a number, a series of electrical impulses goes out directly to his set's transmitter-receiver. The device's battery feeds the transmitter-receiver, which amplifies the electrical impulses coming from the handset and sends them on to the cellular telephone's antenna. By vibrating, the antenna converts the electrical waves from the transmitter-receiver into radio waves. The signal from the antenna of the cellular telephone reaches that of a cellular transmission site practically instantly. These transmission sites are located in the center of small geographical zones called cells. The cells are the functional units of cellular telephone networks. They clearly delimit the zones served, and their size and shape depend on geographical factors and the number of users. The diameter of a cell usually ranges between 1.5 and 28 kilometers. This configuration, particular to cellular telephone networks, maximizes the quality of communication. Indeed, a line of communication always goes up between the user and the transmission site of the cell in which he or she happens to be. The site is never more than a few kilometers away. Moreover, 2 cells, even if close together, never use the same frequencies. This prevents interference between user calls. Cellular transmission sites consist of a transmission tower with 3 filiform antennae and an equipment hut. Incoming radio waves from a cellular telephone are picked up by the transmission tower's 2 receiving antennae and forwarded to a mini-computer and to the radio communication unit in the equipment hut. The mini-computer recognizes the signal from the user. The radio communication unit then sends the signal received to the central switch. The central switch is rather like the brain of the cellular system. Its job is to orchestrate communications between the system and the telephone network as a whole. When it receives a signal from the transmission site, The central switch assigns the call a particular frequency, called a channel. The central switch then forwards the call via the conventional telephone network to its recipient. Two-way communications are ensured by the transmission site's third antenna, the sender antenna. Cellular telephony also enables communications between mobile telephone sets. When the central switch receives a call, it searches for and locates the user being called. It then assigns a channel to that user. Drivers may leave one cell and enter into another while they're on the phone. When this occurs, the central switch is notified immediately and assigns the user a new channel. The operation, taking only a 20th of a second, goes unnoticed by the user. Because the cellular telephone and conventional telephone networks are so closely linked, cellular telephone users can make long-distance calls even abroad. Cellular telephone technology continues to progress. There are sets made today that will fit into your briefcase and even your pocket. More and more, the cellular telephone is extending into areas other than business and personal communications. It is an excellent emergency communications tool. Cellular telephone networks have even been installed on some highways, so drivers in difficulty can call for help. That's the kind of versatility you can expect from a cellular telephone. What next? Well, we can look forward to the cellular Visiophone. That's a cellular telephone with a built-in picture. For the time being, the Visiophone is not quite ready to be marketed. And no one knows for sure whether it would be that popular. I, for one, would not be amused to be caught off guard by my producer at 4:30 a.m. on the morning of a shoot when I'm still half asleep. For a time, we thought that the new technologies might signal the end of paper as the main support form of information. Not likely. Do you have any idea how many photocopies are made on our planet in a day? Xerox is only too happy to tell us. 2 billion copies per day. That's a lot of zeros. Since the advent of the first photocopiers, methods for document reproduction have evolved at a fantastic pace. Today's photocopiers can make dozens of copies equal to the original in 1 minute. While at the cutting edge of time, the technique they employ is based on a process that dates back 50 years, xerography. Xerography is based on an electrical property called photoconductivity, found in certain materials. In darkness, the photoconductive materials can accumulate and store electric charges. When exposed to light, however, the materials lose their electric charge. A photocopier is centered around a rotating belt or drum, covered with a thin layer of photoconductive material. This is what happens when you press the on button of a photocopier. In the darkness, a fine electrical wire connected to high voltage sweeps across the drum, covering it with electric charges. A fraction of a second later, the photocopier's lamps turn on, lighting the document placed on the plate of glass.
The dark areas of the document, such as the written characters, absorb the light. But the pale areas, such as the blank spaces between the text, reflect it. Thus, an image is created consisting of areas of light and of shadow. A system of lenses and mirrors projects the image onto the photoconductive material on the drum. When they reach the drum, the pale areas of the image neutralize its electric charges, and the dark areas of the image leave the electric charges intact. The image of the document is thus outlined in the form of electric charges on the drum. To become visible, the image must then be developed, and this is done by a dry ink made up of tiny particles of resin. Small steel pellets convey the particles to the drum. These particles are negatively charged. They are attracted to the positive electric charges on the drum and adhere to it. A visible image of the document then appears on the drum. This image must be transferred to a sheet of paper. The paper conveyed by the photocopier's paper feeding system is first charged electrically, then brought into contact with the drum. The ink particles detach themselves from the drum and cling onto the paper. The copy is almost finished. For it to be handled without damage, it is heated to a temperature of several hundred degrees. The ink particles melt and imprint the fibers of the paper. Thus, a dry and lasting copy is made. To make another copy, the drum must be exposed to a light source to neutralize the remaining charges. While none of the basic principles of the photocopy have changed, modern photocopiers are quite different from their forebears. They produce high-quality copies in less than a second, almost completely automatically. Models have multiplied and diversified. The more sophisticated machines have a built-in computer to control each step of the operation as well as copy quality. By adjusting their optical elements, such machines can produce an enlargement or reduction of the original. The copier can even diagnose malfunctions and notify the technician by telephone when there is a serious problem. A number of new document production methods use the xerographic process. The color photocopier generates high-quality color copies through the use of colored filters and inks. For its part, the telecopier or fax machine reads documents and translates them in a coded form that can be sent by telephone line. A second telecopier decodes the document and reconstructs the image on paper. The most promising of these techniques is the laser printer, a combination photocopier-computer. Written information in the form of a diskette or magnetic tape is processed by the computer, which gives the text the desired format. The modified information is transmitted by a laser beam, whose impulses create characters and drawings of unparalleled precision and quality. Today, laser printers are used for a great variety of purposes, from printing invoices to supermarket labels. Thanks to these new document processing techniques, the boundaries between paper and electronic memory are fast disappearing. Most of these new machines have their own special way of communicating with you. A display screen of electronic indicators that light up shows you the procedure. But the conversation remains pretty limited. Why haven't these machines been equipped with a computer you could talk to and that would answer back? Scientists are still having trouble fine-tuning a computer with voice control. Mind you, it is a tall order. No machine can match the plasticity and flexibility of a human being. For a computer to be able to converse, it would have to have in memory a data bank such as the one we acquire as children,
with our senses, feelings, and intelligence. For the time being, the researchers who are working on voice and speech syntheses and recognition are making progress, albeit slowly.
Up until now, in order to communicate with a computer, you had to master its language, the keyboard, the mouse, and the cathode ray screen. Soon, all this will change. Thanks to computer synthesis and speech recognition, simple machines can already comprehend a human's oral instructions and reply aloud in an intelligible synthetic language. Devices that can pronounce words and simple sentences have already been installed in telephones and cars, for example. But their limited vocabulary consists only of pre-recorded words and sentences. This voice synthesizer, however, can read any word or group of words aloud. Its use is simple. The text to be read is entered by keyboard. In the device, all the letters in the text, together with punctuation and spaces, are translated into computer language digital codes made up of zeros and ones. Each letter of the coded text is then converted into a phoneme. Phonemes are the smallest units of speech. To effect the conversion of letters into phonemes, the voice synthesizer relies on 800 phonetic rules and a dictionary stored in its memory. It also sets the length and emphasis for each word, sentence intonation, as well as the pauses and links between the words and sentences. The synthesizer thus produces an oral version of the written text, which is spoken by a loudspeaker. This voice synthesizer can be used, for instance, to read aloud to persons who are visually impaired. It could also help build veritable sound libraries for the blind. For computers to respond to human voice instructions, they need something else. They must be able to understand human language.
Felix, open the door.
But for a machine, it is even more difficult to recognize speech than to synthesize it. The way a word is pronounced varies greatly from one person to another.
Felix, open the door.
Voice not recognized, command refused.
A computer used to instructions that are always the same finds such differences in pronunciation hard to interpret.
Felix, what happened today?
Today I transferred 3 telephone calls to your answering machine and stored the electronic mail in the computer.
The voice-controlled house is not yet a reality, but current research in speech recognition could make it one soon. However, researchers have been able to develop a voice recognition system capable of overcoming a number of these problems and of recognizing over 100,000 words. The system analyzes sound waves emitted by the person who is speaking. The person's voice, picked up by a microphone, is first broken down into a series of sound spectrums describing the variations of intensity and pitch of the sounds. Through comparison with sound spectrums previously recorded by several subjects, the computer picks the phoneme that best matches each sound spectrum. After all the phonemes of the text have been identified, they are translated into letters and words, then into digital codes that the computer can understand. Some telephone networks already offer their customers services that use voice synthesis and speech recognition techniques. These services give users a choice of available information like the weather or the horoscope.
What is your sign?
The user selects the information he wants, and the computer at the end of the line answers the questions.
Would you like information about another service?
Once fully mastered, these speech synthesis and recognition techniques will probably become part of the many information and communication tools of daily life.
Felix, give me the news headlines of the day.
Certainly, the President of the United States will address the nation tonight.
I usually carry anything I might need in my handbag: notebook, pens, flashlight. Imagine all the things I could be stuffing into it in the future. A cellular telephone. A personal computer. Mini fax machine? And what else, pray? I have it. A book.